Hey everybody. Today we're talking about single variable data visualizations with focus on histograms, frequency polygons, and ogives. The motivation here is that looking at a raw data set is almost never helpful. It's just a sort of wall of text. And the best way that you can get a feel for a quantitative distribution is by making a graph. The most important sort of graph for quantitative data is the frequency histogram, like the one we're seeing here. Data values are represented on the horizontal axis, and frequencies, or counts, are on the vertical. And so this histogram that we're looking at here was built by me using the data from the previous slide. It's a lot easier to understand and to think about, isn't it? In order to make a histogram by hand, you first have to construct frequency distribution. The previous video in the Normal Knowledge College Statistics course is about frequency distributions with an emphasis on understanding. If you're just dropping into this video through a Google search or something like that, and you need to know how to do this, I'll have a link up top so that you can follow that and get that information. More frequently these days, histograms and other data visualizations are made using technology. Even if you are making your plots using technology, like I always am, you're not excused from understanding what's going on there. You have to know how to read them, how to interpret them, how to explain them, and from the construction standpoint, you have to make some human decisions about the construction. For instance, in a histogram, at minimum, you have to decide how many classes you want, how many bars you want, or equivalently, how wide they should be. Now, a few things that you should note about histograms right away, and the first of these is really the most important. Histograms represent frequency with area, and so the eye is drawn to the parts of the plot where there's more ink. More area means more data. Secondly, the shape, center, and spread of the data are all visible in a histogram, and so right away this is a major advantage over just looking at the data itself or at some simple summary statistics about the data. Finally, and a bit more technically, there are no gaps between classes in a histogram, and this reflects the fact that when we're making a histogram, we're graphing quantitative data that's broadly speaking on a continuous scale. Gaps between the bars would seem to indicate that there's gaps between the classes. Usually when you see gaps between bars, we're talking about categorical data. We're talking about a bar chart rather than a histogram. Long story short, have your bars directly adjacent to one another when making a histogram. Now there's a lot of variations on the histogram that are worth mentioning sort of in passing. Up till now, I've been labeling the boundaries of the classes, for instance over here, 52, 60, 68, but it's perfectly legitimate to label the midpoints, 56, 64, 72, and so on. And in particular, the plot does not change shape when you make that change. Similarly, instead of plotting frequencies on the vertical axis, we can plot relative frequencies, so just the frequencies divided by the total sample size. This is called a relative frequency histogram. The shape doesn't change. Here I've gone back to labeling on the x-axis the boundaries, but again, I could label the midpoints, same shape. Another very similar plot is the frequency polygon, and we're graphing exactly the same information in a very similar way. The big difference is that instead of representing counts using bars, we're now doing it using points. The shape is fundamentally the same as for a frequency histogram, and to illustrate that, I'm going to flip back to the histogram on the previous slide. So take a good look at this, and notice how the first bar is a little taller than the second, and then we go up a tiny bit to the third. Same shape here. One difference to note is that here an extra point is added on the horizontal axis at each end, so that really does make it a polygon. And this indicates that the full range of the data is being shown on this plot. All of the things that I've said previously about the slight modifications to frequency histograms can be applied here. For instance, on the vertical axis, instead of just showing counts, we could show relative frequencies, that is, proportions instead. Finally, we can represent data with an ogive, also known as a cumulative frequency plot. And here on the x-axis, we're putting upper class boundaries, and on the y-axis, we're putting cumulative frequencies. So each plotted y value shows how many observations in the data set lie below the corresponding x value. By the time you get to the far right on this plot, you should get the y value to be the total sample size in the data set.